Assalamualaikum and good evening to all. Okay, today we're going to continue our new module. So I hope that all of you already understand in deep, especially for your module 3. Yesterday we did finish our module 3, right? Okay, now I'm going to open our new module, which is the things that I always repeat about our Boolean. Eh. Okay. So last time I already informed that later you're going to learn on Boolean. So Boolean is one of things that very important for you to know in the digital logic subject, because I don't think that others like a basic gate, combination gate is hard, but when you try to play around with Boolean, I think it is much more hard, especially when you need to remember laws, rules, theorem. So a lot of things that you need to remember. If you can't remember, of course you cannot apply. But if you can remember, but you don't know how to apply also, it will be a problem. So that's why I think for Boolean expression is much more harder if you compare to others. Okay, now let's take a look what we're going to cover in our module 4. Before we go deeper in our Boolean, we will have several things to get familiar first. First of all is on the variable. So on the variables, or it called as pemboleh ubah in Malay. I always mention that you can have A until Z as your variables for your input or your output. And normally the characteristic of the variables is italic, uppercase, but sometimes we have also limitation in our e-learning. Sometimes it is not italic, but as long as you understand, yeah, that is the Boolean expression and it is represent as a variables. I don't think that there is something else rather than variables in your Boolean expression. Okay, next is our complement or pelengkap. You know already that we several times discuss about our complement and inverse or inverter, which is we learn on our module 1 and our module 3. Our module 3, we look into the not get. And we know that it is represented as bar or prime, isn't it? And I also already mentioned to you that we prefer to use bar last time, okay? since like last semester we prefer um, A bar, but I don't know whether this semester we like moving to A prime, but it's depend on the lecturer itself who wrote the question. As long as you know, okay, bar and prime is basically similar. It's referred to the toggle thing. It's referred to the complement. It's referred to the inverse. If you have the input A, it will be toggled to be 0. Otherwise, if you have 0, it will be toggled to be 1. That is on the complement or pelengkap. While for the literals, both variables and it complement in a term. So where is your variables? This is variables, this is variables, and this is variables. Okay, maybe I give you an example. F equal to A B plus A prime B. Kenapa I guna prime ni? Okay, for this expression, how many literals? Sekejap I pergi tengok mana section 9. Oh, after recording, I cannot see. Okay. Kenapa ada bunyi dekat sini? Muhammad Alif. How many literal?
5.
Faris?
Four.
Lai Kai Chen.
5.
Okay, so when we want to see the literals, Alif is mentioned as 5. Maybe I think he got like A and then B and then A prime and then B again and then B bar. So for Faris, I think it is like remove this, so it's equivalent to 4. So let's see what is basically the answer. So if you basically have also, you can see there is also like X bar. So although you have similar here, which is you have B and B for this part, you need to also calculate. Means that from this you have all together as a B, 5. So another example, you can see over here, you have F equal to X bar Y bar plus X bar Y. So from here you have 1, 2, 3, 4. although you have x bar 2 times repeating, but you need to calculate also. That is on the literal. Okay, understand? So let's say I have another example. A plus B, C plus A plus B. I repeat. Okay, just example. So you need to calculate every single thing. Although you have like B bar, and here also B bar, you need to calculate. This is also your total of literal. Now, from this example, you can also got the variables. Also, variable is very like easy because it is input. So how many inputs that you have? You're going to calculate only on the difference variables. Okay, you have x and y. Although it is bar or there is no bar, basically it is only one input. Let's say you have a, and then you have another one is bar. This one is a, this one is a bar. Your starting point, you have only one variable. So that's why you calculate it as a one variables. So two variables, x and y for this example. And the term, how about the term? The term will be separating. Okay, for this example, it is like pause. Later, you're going to learn also SOP, how the Boolean expression will look like. For this equation, you're going to have two terms, 1 and 2. Later, you will also have like this, like A plus B, B plus A. Let's say I just give you example. So both of these have a different kind of representation. Sometimes the question will ask you, represent using a SOP, represent using POS. Which one is represent as POS? Which one is represent as SOP? But over here, you can see this is one term, this is another term. Not because of this plus, but this is divided into several terms. Okay. So it is not too hard. Later on, you will think that, why I need to learn all the rules. Now, you have law and rules of your Boolean algebra. So under rules, you have 1, 2, 3. First is your commutative law. Then you have associate law. Lastly, you have like distributions law. Where you're going to apply and how you're going to apply all of this. Let's see the first law, which is you have two things, additions and multiplications. First, this one is very easy. You masuk sekolah rendah balik, you will like, this also I know lah. 1 plus 2 equal to 2 plus 1. 3 plus 2 equal to 2 plus 3. Ini kacang saja, which is basic mathematics, but this is the law of commutative law addition. Why? Because you need to apply into the OR gate and etc. So it means that you need to know whether if let's say you like changing the place of the input, you still will get the similar output. This is similar to each other. Okay, while learning our law, let me teach you also how to draw the circuit. Because later you're going to learn on how to draw the circuit. So why not I teach you from now? So no need for you like to wait into specific how to draw the circuit. So from here, I have this example. I know already if it is plus, I have OR gate. OR gate. So how I'm going to define is I have A plus, what is plus? OR gate. B. So I have these looks. For this part, I have B plus A. Although you said, Doktor, this one is very simple. Kenapa ajar macam tu? But as I mentioned, the basic things is the most important. I'm not going to teach you like something like, okay, you dah tahu this is O git. And then directly you need to like apply how you connect your input, how you connect your output, and etc. So you're going to be like very confused later on. So from basic, I will teach you how to draw it one by one. So that is, you can see, let's say I give you example for this part. You have A or B. A or B. So you get the output if let's say the output is F. Let's withdraw the input. This is my A. This one, kalau you tak pergi tunjuk sini pun, you already hafal, right? You already memorize it. You will get 0, 1, 1, 1. But we want to prove. To prove, you need to learn in terms of like drawing a circuit and show it in using a true table. But sometimes proving also in question will ask you prove using a Boolean rules or prove using a true tables. That's why I teach you, although it is just a simple get on. Okay, now you got this part. How are you going to prove? You need to do this part and then you need to compare with the output. Okay, now we have B add addition with A. B add A, I have my F. How am I going to look like? My F, of course, I'm going to get similar. See, this is my output. A plus B, B plus A equal to output at my A plus B. So I prove. So you need to draw this truth table and this truth table to prove that your answer is correct. Why I said so? Because there is a question asking you, okay, please prove this commutative law. Please prove this commutative law using truth table, using Boolean expression. So you need to know all method. Okay. So one by one, I teach you from basic to like a very complicated one. Okay. That is on our addition. We also have another, which is our multiplication. If you think about multiplication, you know already it is a AND get. Let me see over here. I have A dot, which is multiply my AND gate with B. So this is how I'm going to draw my circuit, although it's very basic one. So I have my output. How it's going to be look like? Proof in terms of your true table, let's say. So I have 0, 0, 0, 1, 1, 0, 1, 1. My F will be, okay. Then I need to do this part. B multiply with A. This is my output. B A 0, 0, 0, 1, 1, 0, 1, 1. My F will 0, 0, 0, 1. So it is basically similar. Over here is B dot A. Here is A dot B. Oh, my output is similar. So I prove it is a correct. So in terms of later on you're going to learn on rules. There are altogether 12 rules that you need to remember. So there is also another one, which is Proof using Boolean rules. Proof that this commutative law is correct using a Boolean rules, but we didn't yet cover our rules, so later on you will see. Okay. That is on commutative law. Now we have like more complex, which is associative law. Okay, we have this one example. Okay, we have this example. A plus factorize C plus B, A plus C. Okay, in mathematics, as I mentioned, this is like a simple mathematics. You know already when you have like 3 plus 7 times 5 plus 2 factorized with 3, or maybe factorize 7 minus 1. Which part you need to do first? First, you need to do the factorize, if you still remember. Second, you're going to look into multiplication or divisions. Third, you're going to solve your additions and also subtraction. So this factorize, you're going to solve this first, you're going to solve this first. This will be 6, this will be 6. Plus, you need, after this, you're going to do number 2, multiplication first. So you're going to solve, you get T, multiply, you have 35 plus 6 plus 6. So this is just example. So the method that you need to apply into your Boolean. As we apply it to draw our circle. From here, I have A plus factorize B plus C. So I'm going to solve this first. I have B. This is my get all. B plus C. I solve this one. And I can see there is another addition, which is my answer. This is my answer, which is the output. Will add with, oops, with my A input. So this is my output F. Okay, this is I teach you how to draw. For this part, let's say I have this factorized. I solve first A plus B. And then I plus again the answer. I plus with C. I get the output. Let's take a look in terms of proving by using the truth table. Okay, we see this first. I have what? A, B, C. Kena ke atas sikit. Mana I punya pen ni? Okay. A, B, C. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. I hope that you know it is from 0 to 7. Altogether is 8. And I have my, you need to do step by step. Later I will like show you how I speed up. Okay, first you have B plus C. And then you have B plus C plus A. This is your output. This is your truth table over here by proving using truth table. For here, you have 0, 0, 0. You will get 0. And your A also 0. Then your answer, sorry, we do this part. So first, 0. And because this is OR gate, I know that I will get all others as a 1 for my B and C. Now I go to my E plus B. Okay, I will like stop over here because basically when I'm going to repeat the same thing because I have the similar input for my B and C. Now for my answer for B, C plus with A. Because it is O, as long I has at least 1, I'm going to get a 1. The rest are going to get a 0. So if let's say I have 0 and 0 here, I will get 0. So I will check here 0, here also 0, here 0, but this is not 0. So I'm going to have 0, 1, 1, 1, 2, 2, 3, 4, 1, 1, 1, 1. So this is my final answer. Let's check this part. A, B, C, A plus B. My final answer is A plus B plus C. Oh Allah, saya ingat juga. Tak kena pakai pembaris. Tak nak drawing ni. Okay, I have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. And then 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Altogether, 0 from 7. We have 8 possibilities. Now we have A and B. It is OR gate and OR gate. I'm going to get, if it is 0, 0, it is 0. The rest will be 1. But for OR gate over here, I need to see carefully because it is beside here, not at the end. So as long as it is 0, 0, I'm going to put 0. The rest will be 1. 1, 2, 3, 4, 5, 6, 7, 8. Now I have A plus B. I can see whatever input 0 here and C 0, I'm going to get 0. The rest will be 1. So I will check my AB as 0 and my C is also 0. So here is 0. The rest will be 1. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so why the answer is similar? Because it's similar means that A plus B factorized plus C equal to B plus C plus A. Isn't it? So it's very easy for you to prove. As long as you prove this, then you get the total marks. Okay, in terms of like, no need for you to like directly one by one doing. If let's say I have this B, C, A, B, C. Okay, how I'm going to get my F? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay, from this part, my F is, I'm not going to like finding A, B, and C output here. Whenever I have A as a 1, I'm going to get 1 for my output. So I can see I will put here all as a 1 first. And over here, whenever I have 1, means that I'm going to get 1 also for my x. But to get 1 here, I need to have either 1 as a 1. So whenever I have at least 1b as a 1 or 1c as a 1, I'm going to get also 1 for my f. So here is 1, 1, 1. And only this part there is no 1, so I put 0. So directly, I'm not going to like see one by one. But for your, this one is like maybe for your objective case, multiple choice. You can like directly speed up your answer. But for your step by step subjective, you need to have all the table. Later you will see there is another one example for you to do. Through table. Now you can see this is the example of the circuit. And for this part, you can see we have A factorized B dot C. Okay, what we're going to solve first, this one, right? Because it's factors, we have B multiply with C. And then this output will be multiply with our A. While for this part, we have A multiply with our B. This output will multiply with our C. So you need to prove these two is similar. So you draw the truth table and you define. Basically, you can just direct apply in your mathematical. Let's say you have 2 times 3 similar to 2 times 2 times 3 is basically similar. And whatever number you can put, it is represent as the variables also. So this is the representations of the associative law for multiplication. You try to draw your own truth table. Okay, for this part, maybe I can like directly give you my expression. I prefer to use my own circuit. I have B multiply with C, and the output multiply with A. Okay, let's take a look. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay, this is my, of course, my ABC. And I need to find my F. How I'm going to like easily get the output. So first of all, I'm going to look into this. Okay, then I know this is AND gate. How I'm going to justify? I'm going to get only 1 for my output when I have at least A as a 1. But if I have 0 at least for my A, the rest of my output also will be 0. So let me find 0 as my A. So I have 0, 0, 0, 0. So all of this, of course, my output will be 0. Directly, I'm not going to like think anymore. I directly apply, okay, if it is A as 0, then everything will be 0. I'm not going to see anything about my B and C. Because I know if one of the input is 0, it's totally 0 for my output. Next, I need to have, if let's say I get at least 0 for my output for B dot C, which is any input got also 0, I will get 0. So my output will also 0. So I check whatever value, if let's say B or C got 0, also I put as a 0. So let me check below here. This is 0, 0, 0. So that is a possibility to get all 0 there. And how about if let's say I have 1, 1, 1, 1. So all others is 1 means that I'm going to get 1. So directly without like check one by one, I can like getting my output. How about this one? I have A multiply with my B, and the output will multiply with C. So similar, I'm going to look into my, this is my output. I'm going to look into my C. Whenever I have 0, average 0 at my C, I'm going to get 0 for my output. So I'm going to check 0, 0, 0, 0. The rest I still don't know yet, but I'm not going to refer here first. Then next, I'm going to see, oh, if let's say I have 0 here, at least all the output also 0. So from here, at least I have 1 0, it will effect to be 0. So let me check my A and B. As long as it got 1 0 also, I will put as a 0. So that's why I get the similar things. Now, you have another more things, which is your last law. Your last law is A factorized with B plus C. So what I'm going to solve first, which is B add with my C. Get O. And then this answer will multiply with my A. So this is the circuit for this part. And for this part, let's say I solve the multiplication. I solve the multiplication first. I have A multiply with B. And I have A multiply with C. And for this is one input, this is one input. I have another one is add. This output will be adding together. So you can see it is totally different circuit. But is it correct? Of course, in the mathematical, if you look, of course lah doktor, bila we directly multiply, we will get AB plus AC. But in terms of circuit, you will see, correct? Something like that. So let's draw. We still didn't learn the rules right, so we cannot prove it using our rules. That you might confuse. So this is my output F1. This is my output F2. I have A, B, C, 0, 0, 0. Oops. Okay, now for this circuit, of course, as mentioned, you need to like check one by one, B plus C, what is the answer, 0, 0, 0, 1, 1, 0, and etc. But for me, I'm going to speed up. You need to try to have like B plus C and then your answer over here. So for me, I'm going to look into the input here. Number 1, this is AND gate. So the same situation, if I have at least 1 0 at my A here, everything will be 0 for my F1. So let me see. 1 1 1 1 for 0 0 0 0 for my input A. Next, at least zero here, it will affect all to be 0 for my f. But how to get 0 here? This is OR get. OR get, you will get only 0, 0 when B and C is 0 and 0. So I'm going to find that one. B and C is 0, 0 is this part. So the rest will be 1, 1, 1. So this is my output for my F1. Let's see this part. So for this part, I know basically if I have how I'm going to get 0, 0. If I have output as a 0, 0, I'm going to get 0 for my F. But the rest you will get like 1, 0, 0, 1, you will get 1. And of course 1, 1 also you will get 1. So from here I want to find 0 for my F1. How to get 0, 0 here? Of course, at least, okay, at least this 0 and this 0 and this also 0. At least each one of these will affect to be a 0. If let's say A is 0, answer here will be 0. If let's say you have B as 0, although the A will be 1, also you get 0. And that is on the A and B. You can see over here, if let's say your A is 0, it will affect also the input of your C. So this one is also will be 0. And if your C is okay, if let's say you have 1 here for your A, you have 0 here for your B, and you have 1 for your C, you will get at this part as 1. So you need to find also the possibilities of this one. Let me try to do it first. Oops. So just now I already get at least I need to get all is 0 to be get as a 0 for my output. And how I'm going to get it? Let's say over here I need to have A as 0 and also C as 0. If let's say I have A and C as 1, I will get 1. A and C as 1, I'm going to get 1. A and C as 1. A and C as 1. Okay, so I have this part first. Then it's settled to be 1, 1 first. And then, if let's say I have another one more thing, if let's say over here I have 1. So how I'm going to get this part is 1 is A and B is 1. So A and B is 1 is here. So that is only that possibility to have 1. The rest will be 0, 0, 0, 0, 0. So it's depend on you how can you do it. As long as you like, maybe you try many exercise, then you know directly you can like apply. Otherwise, you need to do it one by one. A dot B, what is your answer? A dot C, what is your answer? And then you can justify your final value of F2. So for me, I already like familiar with and or, so I can directly putting the truth table. So you need to justify about that, which is you can see F1 and F2 is similar, although the picture of the circuit is different. that is about laws that you need to remember. Any question before we moving to our rules? Any question? Any question?
No question, doctor.
Okay, so then I'm going to move to my okay. I want to copy this before we move to alamak ada jawapan pula. This one is basically I already proved. Let me like screenshot. I'm going to share it into my Jamboard. Jamboard. Where is my Jamboard? Muhammad Haikal.
Yes, doctor.
Okay, I want you to go to this link. I will give you to the chat. Go to the link and I'm going to share. Please draw and proof the using the truth apple. Eh. Kenapa jadi kecil? Okay, much better I think. You need to draw and you need to fill in the truth table.
Doctor, it said the access denied. I need
Huh? Wait ah. Allah, kecil sangat dah. Okay then. Can you edit?
Okay, wait.
Okay. Hah? Tak tengok. Apa benda? Mana you punya circuit?
Oh, kena buat circuit dulu.
You need to draw the circuit and then how like we know. But it's okay. You can like put the value also for the input.
I put the value first later.
Mm. Pakai pembaris. Okay, any explanation?
Um, mm, Doctor, do I need to explain this?
Uh, maybe.
Uh,
Kejap,
is
before you explain, Huam Jun, is it correct?
Uh, yes.
Okay. Gan Heng, is it correct?
No,
Okay.
because
Okay.
we less one.
Yeah.
The 110 at the
Yes.
ABC 110. We forgot to write.
Dengar tak?
yeah, Doctor.
You, you missing something, especially for your input. And then, of course, when you don't have input, your output also will be effect.
So, Doctor, do I need to explain this?
I think I already explained in the associative law. Just want you to like recap only. Okay, I hope that everyone getting the similar things because this one is just now I already explained in the associative law. Now we need to move to our rules. Mm, Thank you, Haikal, for your drawing and for your answering the question. Now let me proceed. Stop sharing pula. We need to proceed to our rules. See, you have altogether 12 rules. Although you are the one like maybe, Doctor, this one is very easy. I am a type of person who can like memorize things very easy. You just name it. Which rules that you want me to see it or mentions? Let's say rules 8. Oh, I know rules 8 is A dot A bar. Rules 11, I know what is the rules. Although like some part of us like maybe we don't know basically what is the name of numbers rules, but we know okay A plus 0 equal to A. But maybe you are the one that really can memorize all things. You can memorize, but if you don't know how to apply, you cannot also answer the question. And if you like maybe you know how to apply but you like rarely do the exercise, and it's hard for you to do the simplification, and sometimes there is also hard question for the proof. So that's why it's better for you not only to memorize the rules but also you need to do exercise. Let me go to directly our rules number 10. Why rule number 10? Because in this slide it's give you later on this example. Okay, let we see here. Later we will look into all the rules, but first let we prove. How come we can get A plus AB equal to A? Maybe I have like, of course we have a 0, 1 value only, right? Maybe we have A plus, if our A is 1, our A B equals to A. Our A here also will be 1. So B maybe 0, or maybe B is equal 1. Later on we'll see the things. 1 plus 1 we will get also 1, which is similar to A. And if let's say it is 0, 1, it will also follow the A. So, but it's okay. No need for us also to be headed if let's say we cannot like apply in a numbering for the mathematical things. So, how about we draw the circuit? For this part, you can also, as mentioned, you can be asked using your rules. Proof using the Boolean rules. Or rule a proof using your truth table. So now we're going to look into truth table and rules. So for rules, you can see here, although like you still not learn this one, but you can refer. I can factorize using a normal mathematical. I have A 1 plus B. Similar, right? This is mathematical factorizing. And after that, I can refer to rules number 2. 1 plus B equal to 1. It is doesn't matter, although it is not A, but we know this is one variables or one input. So now our input is B. 1 plus B or B plus 1, which is equivalent, equal to 1. So we have A, 1. So our answer will be A, which is A plus AB. So proof using our rules of Boolean. Now maybe we need to prove using our truth table. Let's see, we have here, we have multiplication. We have A multiply with B. And this answer we have adding with the A. So let's see, I have only 4 possibilities, 0, 1, 0, 0, 0, 1, 1, 0, 1, 1. This is my F output here. You need to like do A dot B and then finally you have F. But you can try to do this. I'm going to directly go to my F. So as long as I have here S1, I will get my answer for F1. So I put 1, 1. At least I have 1 for my A. I'm going to get 1 for my output. This is OR gate, isn't it? So now, I need to also have at least 1 here. So how to get this as a 1? I need to have A and B both as a 1. So where is it? This side. So here is already 1. So the rest will be 0, 0. How to prove? You can see this is totally similar to my A. So that's why I can see this circuit is getting the output of A, similar things. So I prove already. Is it okay? So that is 2 ways for you to prove that we see in a proper picture. The truth table, the one that I created. This is our F. So normally you're going to draw the A, B, but I prefer to directly. I got 0, 0, 1, 1, which is equivalent or similar. That's why we prove it's equal using truth table. Another one more using your Boolean's rules and Boolean law. You can see first you're going to use a factorizing using distribution law. And using rules number 2, 1 dot B equal to 1. This part. And after that, rules number 4, which is if you have a dot 1 equate to SA. So you prove already. So there is 2 ways for you to prove. It depends. Sometimes the question asks you. Sometimes it asks you specifically using what. But sometimes it just mentioned, okay, please prove that it is correct. So you need to prove either one. We can choose using truth table or using Boolean algebra. Next, you have rule number 1. Let me see. We have a plus 0. A plus 0. This is ground. Why? Because ground we know that it is 0. And this is our output. Our output, whenever you have 0, 0, you will get 0. But the rest, you will get 1. So you can see over here, we have A, and also this one is, let's say, B. And we know our B is always 0 because our input is 0. A So this is our output, which is similar to A. Means that we proved already A plus 0 equal to A. And it is like also our mathematical, which is if we have 7 plus 0, we will get also 7. 9 plus 0, if we got a 9. So it's very simple. Second, we have A plus 1 equal to 1. In mathematical, we cannot apply because whatever we add, we will get the value. But when you apply with 0, 1, 0, 1, then you can see directly. Okay, we have A add with 1 VCC. As mentioned, assume it as to be AB. And our B now is always 1. Our A will be either 0 or 1. Get O. This will be get 1. This one will be get 1. Get O. So this is our output. And it is always 1. That's why we will use A plus 1 equal to 1 because our output will always 1. Either it is 0 or either it is 1 because you only have 2 possibilities for our input variable this. And you know already for get O, whenever you have at least 1 as your input, your output will also 1. Means you already have 1 here. That's why you get 1. Although your A is 0, you will get 1. And of course, if you have A is 1, you will also 1. So that is 2 rules that you already proved. Now, rules number 3. For rules number 3, we have A dot 0. A multiply with 0. We have B, which is always 0. We have A possibility whether it's 0 and 1. This is our output. This is our AND gate. If our AND gate, we know that we need to have A and B to be 1. But there is no possibility B to be 1. It always 0. That's why your answer will always 0. It means that whatever inputs that a dot or and with O with 0, you will get also a 0. Although your A is 1, you will also get 0. If you have A as 0, of course, you got also 0. So this is the rules number 3. For rules number 4, you're going to have A dot 1 equal to what? So it's need to prove that it is equal to A. You have A multiplied with 1. Your B is always 1 and your A can be 0 or 1. And your output will be this 1 dot A, which is N, you will get 0. This is characteristic of N. And get. And 1, you will get 1. So you can see basically it's similar and copycat whatever input for A. So that's why A dot 1 is what? A value that always fixed for B here. And you will get A also. It is basically similar to mathematical. And number 5. For number 5, you have A plus A equal to A. How is it? You're going to have A or A, which is one similar input. And over here, you need to also like have to input which is A and B, or maybe we put here A1, A2. So this is our F. A can be either 0 or 1. This one is the condition for you to check the OR gate. Now, if A is 0, A1 is 0, A2 is also 0, for you to apply your OR gate, you need to have two inputs, right? 0 and 0, you will get 0. If A is 1, A1 will be 1, A2 also will be 1. For this condition, for OR gate, you will get 1. So it is totally similar and copycat your A input. That's why you have A plus A equal to A also. This is proving by using this circuit. And also this truth table. Is it okay? So any question? Now we move to another 6, which is A plus A bar equal to 1. Okay, on this part, we have A plus with our A bar. Bar is what? Not. We will get the output of F. So let's take a look. Is it's going to get 1? Okay, we have A, we have A1, we have A2. A will be 0 or 1. Every time A is 1, A is 0, our A1 will be 0 and our A2 will be 1. How about our F? This is OR gate. This is our 2 input. That it will be 1. For case of 1, my A1 will be 1 and my A2 will be toggle, the value will be 0. Still, this one is all get at least one input as 1 are going to get also 1 for my output. And that's why I can see whatever input for my A, I still will get 1. That's why you have like A plus A bar, you get 1. Why A plus A bar? You check back here. Oops. This one is also can. You check here. You can see by using this circuit, you prove that your F is always 1. And you can see also if let's say, okay, I don't want to refer to here. This one you can see. And rules number 7. You have A dot A equal to A. How to justify it? I have A multiply with A. A1, A2. A have 2 possibilities, but I need to see my input to apply the AND. I need to have 2 input, right, for my AND. So if A is 0, my A1 will be 0, my A2 will be 0. What is my output? Will be 0. A is 1. A1 will be 1. A2 will be 2. A2 will be 1. Then you will get 1. So it's copycat my A value. That's why A dot A equal to A. Later, you need to simplify. But this one, I just prove to you how and why we have all these rules. And of course, later you're going to also apply. Let's say you have A, B. Okay, sorry. Let's say you have A, B plus C plus B, A plus A, B plus B, B bar. Okay, let's say example over here. Please simplify. You will like getting AAB plus AC plus AB plus ABB plus BBB bar. So from here, you're going to use this. You will get AB plus AC plus AB plus AB. Although it is B, B dot B equal to B. Still using number 7. Plus B, B bar. So there is several others that you can simplify. You can see also you have A, B, A plus A plus A. A plus A equal to A. Where is my A? This is my A, this is my A, this is my A. I will get A plus AC plus B bar. Why I said so? Because I already removed this. I combine this as A plus A equal to A. This is the similar thing as A. My A now is AB. So from here, I have also this part. If you still remember. Oh, not yet. Later on, you will see, okay, at this part. A dot A bar equal to 0. So this one will be 0. Then you get A plus AC. From this part, how are you going to settle it? You have A, you use the law. You're going to factorize it. You have 1 plus C. Now, from here, my law, I have rules number 2. A plus 1 equal to 1. My 1 is A plus 1 equal to 1. Now, I apply here. 1 plus C, I got 1. So, I have A dot 1. A dot 1, look back at the rules. Going to get A. From this long Boolean expression, I can simplify and my answer now is A. So that's why you need to like remember all the Boolean rules, and you need to apply it all like rules number 1, rules number 2, whatever rules, and also with the law, combinations of the law, then suddenly you like getting very simple Boolean expression. So that's why no need for you to only memorize, but you need to also do exercise. Play around with whatever expression you change with your friend, and then together you solve, and then whether you get the similar simplification version or not. Next, we have another one, which is rules number 8. We have A dot A bar equal to 0. Is it correct or not? We have A multiply with A bar. I think I already done this part. Or maybe another section. A1, A2. This one is my F. So I have A1, A2, 0, 1. Whenever I have A1 will be similar, but my A2 will be 1. Toggle, right? This one will be similar, this one will be toggle. And you're going to see this is my N. Both 0 and 1 will be getting 0 for my F. That's why whatever input of my A, either it is 0 and also 1, still I get 0. That's why A dot A bar equal to 0. That's why just now, alamak dah delete. That's why just now I can remove the B dot B bar because it is 0. Now let's take a look into rules number 9. Rules number 9, we have A bar bar equal to A. What is A bar bar? Bar is not, bar is not. We have two. Not, not. So this is our F. If let's say I have 0 for my A, we will get 1 here. And if we have 1 here, here will be 0. If we have 1 here, here is 0, here is 1. So my output will be looking similar to my A. That's why A bar bar equal to A. That is our rules number 9. Now you have like another 3 final rules, which is rule number 10 we already looked into, and now rules number 11 and rules number 12. Here they are solving using several rules and fact and law. So that's why you can see from this you can simplify using this, which is, of course, you can like direct remember, but how you going to solve? How you going to prove? So from this, you have A plus A bar B. Can you prove that it is similar? Where I can draw mine. I want to draw first using truth table. Langsung padam. A plus A. equal to A plus B. This is rule for our 11. Let's redraw the truth table, the circuit for A plus A bar B. We have first the multiplication. I have A, but there is a bar, and I need to multiply with my B. And then I need to add with my A. And this is my F answer. So let me draw the truth table. What is my F? So my F here, whenever I have A to be 1, I'm going to get F as 1. So for my part here, I need to have 1, isn't it? So I need to be looking into my B input and A input. I need to have 1 for my B, and for my A, I need to be 0 because after 0, it will toggle it to be 1. So my answer here will be 1, and this will be 0. This is at my circuit of his. So let me draw this one. This one is also always like OR gate. And we know without any drawing, this is basically similar output for our OR. But yeah, I can like draw it. A OR with B. I have A, B, 0, 0, 0, 1, 1, 0, 1, 1. This is my F. 0, 0. I'm going to get 0. The rest will be 1. This is the condition of OR gate. So I hope that I asked you to remember this, right? For all the basic gate. And luckily, I can see the answer is similar. That's why proof using truth table. I found this one, A plus A bar B for this circuit is similar to A plus B. If you cannot see how I get this, you need to draw it one by one. 0 equal to 1, and then you have 1, and here will be 1, and you also will get 1. And then if here is 1, what happened? So you need to see all the possibilities. But for me, I can like directly get the answer. So that is on the truth table. But when you need to apply and prove, you can see, prove by using the Boolean algebra laws or also rules. You need to make it like apply all the rules that are available. We have A plus A bar equal to, you can make this A using rules number 10. You apply A equal to A plus AB. A plus AB to represent our A here. Then you add with A bar B. You need to think first how you're going to prove. Okay. Then after that, you can apply the rules number 7. A equal to AA. So you have, you have over here A plus AB because you want to apply A here. Then you have A bar B. You add another, you can see rules number 8. Why you add this? Because 0 is nothing happen, nothing changes to your value. That's why you can add it. A plus A bar plus AB plus A bar B. Don't ask me why. Why we want to put this to be A, this to be A bar, AA, this is A bar equal to 0. Why we want to apply this? This is basically your own creativity, how you can apply all the rules into a proving to get the end of your result to be A plus B. So you like thinking how to get and make it to be A plus B using all the 12 rules, 3 laws. From here, you can also factorize it later on. So why it's adding everything? Because they in this example, it's want to factorize. After factorize, you can see and apply. This will be a rules number 6. And you have 1 plus A plus B. 1, you have 1 dot A, you will get also A, right? This is rules number what I forgot already. Then you will get A, which is A plus B. This A is A plus B. So you have two possibilities, whether it is using a rules and using the truth table. Next, your last rules. You have A plus B, A plus C. Later I show you how to like justify using the circuit. You can multiply this, you have A plus AC. Here and here, you got BA plus BC. From here, there are several rules that you can apply. You can apply like this. A, you factorize, you will get A plus C. And here, AB plus BC, you remain this first. Here, you have rules number 2. You will get A plus A, B plus BC. This part also, you can also factorize it again. You can have A1 plus B plus BC. This part, you will get 1. So you have A dot 1 plus BC. At the end, you will get A plus BC. So it proves that your rules number 12 is similar. So instead using these like rules, you can also draw these rules. We have A plus our B. Sorry, I need to factorize first. Okay, it's okay. You can see I do the factorize first, and I have another factorize A plus C. And both factorize, I will do a multiplication. This is my F. And from here, I have another circuit, which is to prove this is B multiply with C, add with A. Okay, so from these two circuits, okay, I'm going to find someone. Kenapa pula saya buat macam ni kan? Macam nak delete? Aduh, hai. Oh Allah. Okay, you can see right. Now, imtizaz.
Yes.
Can you go to the link? I already shared the link at the Gmeets, pages number 2. Please prove using the true tuple.
Kenapa dia lag ambil tu?
Lag ke?
Oh.
I think internet got.
Sekejap lah. Oh, it's baik lagi.
Wait my lecturer call. You can proceed.
Betul ke guys?
Betul dah rasanya.
Betul-betul.
Hello, doctor.
Hello, 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 hello. Pada I bebel seorang-seorang sampai ada cakap, okay, bye-bye. I share my UTM class attendance. Jamboard pun I dah tutup dah.
Kita orang tunggu punya lama, dia tak cakap apa-apa pun.
Tapi you can see that I open my microphone, right? But there is no sound. I was like thinking what happened. I was already said, okay, we meet again tomorrow. But everyone was staying. Aduh, hai. Rupanya saya bebel seorang-seorang dari tadi. After I mute, when I unmute again, I don't know what happened. I cannot talk. Not I can talk, but there is no voice. So I think only that. Just now I already explained that you need to have like two way for you to prove. One is you can use the truth table. Another one is using the law and also Boolean rules. But tomorrow we're going to dig into another theorem. You need to also remember that, and you need to apply in terms of when you want to simplify. So for those who still only one person not yet scan, the rest you can dismiss and meet you again tomorrow morning. Okay.
Okay, thank you,
Thank you,
Doctor.
Doktor.
Okay,
Okay,
thank
thank you,
you.
Doctor.
Sorry
Thank you, Doctor.
for waiting too long.
Tak apa, Doktor.
Bye bye.
Bye-bye, Doctor.
Thank you,
Thank you, Doctor.
Okay, bye bye.
Thank you, Doctor.
Bye bye.
Doctor.
Yeah.
Thank you, Doktor.
In my e-learning untuk course
Okay.
ni content for digital logic course 9 tak ada content.
Bukan tak ada content. Masa exam test hari tu saya hide je. So
Okay.
kejap lagi saya unhide
Okay, Doctor. Thank you.
Okay, bye.
By the way, saya student yang baru tu.
Ha. You need to refer back all the like videos, notes. I think notes only like 2. So later on you need to refer to the video. Okay. If you
Okay,
want to
Doctor.
buy the module, please contact me. Okay.
Do the notebook is necessary?
Because we not going to give any notes.
Oh,
So it's depend on you whether you can like referring to the video, it's okay for you, then I am okay also. There is no like mention wajib kena beli, but kami as a lecturer, the notes basically ada orang yang macam dimiliki oleh seseorang. So orang tu cakap I cannot share and we can only like ask the student to refer to the module.
okay. Notebook tu untuk 4 years ke untuk satu years ni je?
Satu digital logic ni je lah, maksudnya subjek ni saja.
Oh,
So dia ada hard copy dengan soft copy. So hard copy berapa hari tu? 45 including the postage, and kalau you nak drop, you nak ambil sendiri it's 38 or 37. And for the e-books, you can also have e-books similar content but in PDF. Harga dia RM10.
okay, Doctor.
Okay, bye-bye.
Bye, thank you.
Bye.